chapter and a new you, hopefully, that's going to do a little better. We pray. Let's see. I need help with number 1. What can I take out? 6 seems right, but 12 is actually correct. Thank you. So table 6, get a point. We want to take out the largest thing possible. 12 is bigger than 6. When we take out a 12, and we can also take in an xy, we're left with, what are we left with? 3
minus 4y.
Perfect. Every group can have a point. That is hard to read. Okay, on number 2, how many terms are there? There's 4, so you group it. So, okay, so back to this test that I'm frustrated with. Okay, so you graph it on your calculator.
Teachers, please excuse the interruption, but we need to remind everyone to hand out their registration information this morning during first period. If you did not get that information out of your box, if you will send a student to your box, Ms. Dennis and some others are down there, and we'll get those for students. If you're a substitute for us today, then you need to send a student as well to the mail room and let us get that information for them. Thanks, and everyone have a great day.
Okay. I did. Thank you, then. Okay, so on the test, you're supposed to graph them on your calculator. Look to see where they cross the x-axis. Hopefully they cross at least once. You use that point to the new synthetic, and then after that, you might have to factor. You're good at factoring, but you're refusing to get to that point. A lot of people do synthetic and then just quit. I don't really know why. We spent 3 days on it last week. Okay, moving on. So we group. What can I pull out of my first group?
2x.
If I pull out a 2x, well, you can't sit by him, baby. It won't go well for you. It's better for you to be at 2. If I pull out a 2x, what would be left?
4a minus 3.
Okay, and then what can I pull out of the second group? 1 loose point. -3, and what would be left?
4a minus 3.
Okay, perfect. So my 2 groups are
2a.
Goodness gracious. 3 is an easy factor. 2 things that add to 6, multiply to 8. 3 get a point. 1 lose another point. Y'all gotta stop talking baby dolls. I know when you don't take points away, by the way, and then I just take even more. And number 4, it's the difference of perfect squares, so I love it. 2b and 1. And 2b plus 2a, perfect, and 3 get another point. That's terrific. Again, you should get to a factoring point. It should be a grouping problem on your test. After you've graphed it and the new synthetic, our third step was then to factor. There are some problems where I don't have to do that because I can figure out all of the answers with my calculator. But as we've discussed, you've got to look at the degree of the problem. So like number 3, if this was a problem I had to graph on the test, it's degree 2, so I should have 2 answers. I take off a lot of points if it's degree 4 and Arturo doesn't have 4 answers, or it's degree 3 and he doesn't have 3 answers. He at least needs to have the number of answers that matches the degree. That makes logical sense. I will let you resume that very, very shortly. We're going to quickly do a little bit of new notes today because we do need to move on with our lives and start the next chapter so we don't get further behind in life. So you've got your new packet. I told you all our learning targets. We're dealing with the top 2 today. We're going to make it super fast because the top 2 are ones you can handle. And in fact, you've been doing it for a while now. There is a checkpoint tomorrow on what we covered today. So if you are one of my magical, lovely ladies, good Lord, one of my lovely children, it's not just ladies. In fact, Hal is the first one done, so he's not a lady. If you're one of the people who have actually finished the test and would like to go ahead and take this next checkpoint, while the others finish tests. That would be awesome. Because there's a checkpoint tomorrow. In fact, there are 2 different checkpoints this week. It's a very checkpoint heavy week, which is probably good considering how the last test went. Okay, so there's a lot of stuff in boxes. I want to go to the first page. And our first practice one is actually down at the bottom. It says 1A. There are a lot of notes that you can read through if you'd like that do some other example problems, but I'll let you read that on your own if you want. Okay, so when they say f plus g of x, they literally want us to add f of x, which is this. So f of x is x squared plus 5x minus 2. I'm going to color it blue. And they want us to add g of x, which is 3x minus 2. And since we want to add, we're going to combine our like terms. So I've got an x squared, 3x and 5x make an 8x, negative 2, that means minus 4. Are there any questions about 1a? The only thing that changes on 1b is instead of adding the 2 functions, we want to subtract. So if f of x was x squared plus 5x minus 2, we want to subtract g of x. Well, g of x is 3x minus 2. We've got to remember to distribute that negative. So we actually have x squared minus 5x minus 2. And if we distribute that negative, we've got a minus 3x and a plus 2. If you can do that in your head, terrific. If not, because it's Monday, I understand. Again, I want to combine my like terms. So I'll have x squared, negative 5 and negative 3 make negative 8. Negative 2 and positive 2, they end up canceling on out. So that's my final answer. Are there any questions about 1b? I did minus 5, minus 3, got minus 8, minus 2 plus 2, and those canceled out. But if our churro forgets to distribute the negative, he's not going to have the 2's cancel out. He's going to end up with the wrong answer. Is it plus to begin with? Oh, God bless you, Miss Brister. So 5 minus 3, and that should be a 2x. So Miss Compton's made a mistake. Thankfully, Miss Brister caught it. Too bad another group didn't. They could have gotten a bunch of points. It was a plus 5. I wrote down the wrong problem. Surely I can read that the blue is x squared plus 5x. 5 minus 3 is 2. Goodness gracious. Even with that typo, addition and subtraction should be no big deal. We've been adding and subtracting things for a long time. We've just not been seeing it in this notation. The only thing that's changing is the notation. So we can add and subtract. There's no one in here who can't do the top learning target. Find the sum and the difference so you can add and subtract. Good for you. Okay, flip to the back. Obviously, we need to multiply and divide as well, as is life. And we can actually multiply and divide pretty easily as well. The only issue is when we divide, and we'll cross that bridge in just a second. Okay, so I'm not going to read you this paragraph. If you're wanting to look at extra examples, look at the top. I'm going to go straight to guided practice 2A. So they want me to multiply f times g. Well, f is x squared minus 7x plus 2. And they want me to multiply it times g. Well, g is x plus 4. So I need to multiply these two things together. I've got to be really careful when I distribute and make sure everyone gets distributed to. So x times x squared, I get x to the third. Negative 7x times x, I get negative 7x squared. X times 2, I get 2x. But I'm not done because, yeah, I distributed the x, but I still got to share the 4. So 4 times x squared, I'll get plus 4x squared. I need to not write in that color anymore. 4 times negative 7x, I get negative 28x. 4 times 2, and I get 8. And I'm almost done. I just have to combine those like terms. So x to the third, he doesn't have a friend. But negative 7x squared and positive 4x squared go together. Negative 7 plus 4, I get negative 3x squared, good. 2x and negative 28, I get negative 26x. And last but not least, that poor 8 has to come on down. It reminds me a lot of that first chapter 5 test, because we did all this in the first chapter 5 test. The only thing that's changed is the notation, them using this function notation. Otherwise, the math, the combining like terms, distributing, everything's the same. The only thing that's changed is the notation. I say all that, and then we get to 2b, and suddenly life gets a little real. So on 2b, they want us to divide f divided by g. So f is x squared minus 7x plus 2, and they want us to divide by g. Well, g is x plus 4. And this is where we reach our conundrum in life. This is where we reach our conundrum in life.
Right, there'll be eggs. And then you gotta do right?
So, it sure would be nice if we could factor that top for two things that multiply to 2 and add a negative 7. But 2 and 1, no matter how you put them together, never going to get us to negative 7. So sadly, that top is not factorable. But the first thing I think about is, can I factor the numerator? Sadly, on this one, I cannot. But can I factor the numerator? And I can. There's nothing that 1 and 2, and there's no way to get them to negative 7. I was really hoping it would be like what we discussed at the beginning of chapter 5. I was really hoping, and this is not true, so don't write this. I was hoping it was going to be x plus 4, something left over. And then with our x plus 4 in the denominator, I was hoping they were going to cancel out. That's what I wanted to happen. But that's not what's happening in our problem. Sad day. Now, normally from here, you and I would do synthetic or long division to figure out, if we do divide this into that, what is the remainder? We actually don't have to figure out the remainder today. This is going to be our final answer. However, we do need to add a little clause. There is one tiny little thing we need to start adding, and it specifically has to do with the fact that we're in function notation now. A function, which we discussed at the very beginning of the year, very beginning, a function cannot allow there to be a 0 in the denominator. So right now, if I were to plug in a certain number, I would end up getting a 0 in the denominator. What is that certain number I better not plug in? X can be anything except this number, because if I plug in, it's not 0, but let's say I plugged in 0, then that denominator would be 0, and that's a no-no. What's the number that if I plug in right now, life's going to... Negative 4, yes. I heard it first from 2. We're going to give him the point. Now, if you're not seeing that in your head the way Will and I are, all you have to do is take the denominator and set it equal to 0 to help you figure out what the issue is. We cannot have this bad boy equal to 0. We cannot. In fact, you don't have to graph today. It's not a graphing kind of day, but you always can. That or beyond that I can graph in my head. So if you were to graph this thing, weirdo fraction and all, when you do x squared minus 7x, x squared minus 7x plus 2 divided by x plus 4, and again, you don't have to graph this today. I'm just wanting to show you something cool about the graph. So Will said it couldn't be equal to -4, and that's completely true. Notice how, and yes, I'm writing on my calculator. It's mine. I paid for it. I can do what I want. If I zoom out even, notice how it's getting closer and closer to this, but it's never actually going to touch over here at -4. Why? Because that's a restricted part of the domain. We can't actually equal that. So if I zoom down even, zoom out. I want my new center over here. Yeah. Oh, I did a terrible job zooming out. But if I zoom out even, now my -4 is that line in between. It's like it's getting closer and closer to it, but never actually touching it. It's called an asymptote. Anyway, you don't have to know the vocab term, but you do have to know if we divide, there is probably a no-no number that we cannot equal. Because right now, any other number we plug in is going to work, except whatever makes that denominator equal to 0. Okay, it says at the bottom that you have some guided practice problems. Number 1 and number 2 are yours. So the next problem at the bottom and the top problem on the next page are yours, and literally that's all you have to do today. If you would like to finish your test, now's going to be the time for that. Or if you would like to go ahead